Right, so paper 2 questions. Now there were more paper 1 questions than paper 2, so make sure you do practice the paper 2 questions even more than paper 1, particularly as you get to the back end of the exam season. Anyway, so this reaction I thought was really quite interesting, quite tough, because it's stuff you've probably not seen before, because it's asking you about a reaction you're unfamiliar with. So you've got something called hydrated cobalt chloride. What that means, what hydrated means, is that there's water trapped within the cobalt chloride crystal lattice. So you've all seen an ionic lattice, so cobalt chloride will look a bit like sodium chloride, but water molecules are trapped within that structure. They're part of that solid structure. It's not liquid water, you can't boil it as such, but you can do a reaction where if you heat it up enough, the water that's trapped in those crystals will escape and leave you with what we call anhydrous anhydrous cobalt chloride and water. Now, if you were to do that investigation, what you would do is take 2 grams of this stuff, 2 grams of the hydrated cobalt chloride, heat it up really quite a lot, and the water would escape as water vapor, as we'll talk about in a moment. And you can see the mass decreasing gradually. So after 30 seconds, you've lost 0.3 of a gram, a bit more after a minute, and so on. But eventually, after 2 minutes, you'll notice that it stops changing, which means the reaction must have gone to completion. So we're heating. No point heating it anymore, because no further water is being lost. You must have converted all of the hydrated cobalt chloride and anhydrous cobalt chloride. So let's go with this one. So really don't want to spend time particularly on question 1. You simply have to work out the difference between 2 values, which is 24.5 grams, which just about everybody did, I think. So why did the mass of the test tube plus the contents decrease? Well, you had to be clear then that the water vapor was produced. So water vapor or water gas or steam was produced. Okay. Reflecting on that a bit, I might have been a tiny bit generous with my marking there. You had to be clear that it was water vapor or steam that was produced, because it wasn't liquid water. That vapor or steam that was produced, water vapor or steam that was produced, escaped from the flask, or from the whatever it was in. Tube, it was a boiling tube, I think. So that's what the mark was for. So you'd heat it up in a boiling tube, it would just evaporate. No, not evaporate, because it's not a liquid. It would escape from the flask as a vapor. So if you wrote evaporate, I didn't give you the mark because it wasn't evaporating from a liquid. Question 2.3. As I've just discussed this one when I introduced the question. Why did it heat until the mass didn't change? Well, that's to ensure two words, it should be reaction was complete. Alright, question 2.4. I have to say I think this was done really quite well. Energy is taken in from the surroundings. So all of these types of reactions where you heat something up for a reaction to take place, we call them endothermic reactions, or if it's broken down into different bits, they're also called thermal decomposition reactions. And both of those answers, by the way, are allowed down here, but I'll come back to that in a second. So it's a reaction where you are heating it up to make a difference to the reaction. Right, so you're taking 238 grams of the hydrated copper chloride. I'll start again. 238 grams of hydrated cobalt chloride, and that takes in or requires to break those bonds 88.1 kilojoules. If you simply had 2 grams, how much energy would be required then? So that's a simple scale thing, isn't it? So 2 divided by 238, new over old, that's how you've been taught it, times by the energy required for 238 grams, and that comes to 0.7403 and so on kilojoules. But you're asked to give answer to 3 sig figs. That will come up in every single paper, so watch out for that. And you'd have to get 0.740 kilojoules that's required in 2 grams. So well done. And as I said a moment ago, that reaction is endothermic, so it requires heat. It's also a thermal decomposition because it's heating something up to cause it to break down. It's also a reversible reaction. Some of you suggested, and that was right as well. So endothermic was the thing the mark scheme the examiner was looking for. But I'll crack on and do question 5 as well. Sewage. You have to learn about sewage. I don't know why this is part of the chemistry GCSE, but it is. There's no chemistry in this as far as I'm concerned, but we're going to get on with it anyway. So how is sewage treated to remove organic matter? I have to say you did pretty well on this in my experience of marking the set that I marked. You treat sewage first of all by it's called screening or filtering. Off the large solids or the grit that might be in that water. So in sewage water there'll be all sorts of solids which wouldn't ever dissolve that can just be removed. So just imagine it like a big grate, really, like a big metal grate. Take out the big insoluble lumps. The second part, you need to let it settle. You need to do them in the right order, really. So first one is screening, then you let it settle, and that process is called sedimentation. And what happens then is you kind of get your sewagey water and all the organic matter, the poo, if you like. So it's not like organic as in organic chemistry, it's organic as in nasties, poo and so on, fall to the bottom of the tank. So all the sludge, we call it, is down here, and the liquid up the top is up here. So this is called the effluent or effluent. Effluent is up here, and the sludge, great name, is down there. So you get a mark simply for saying screening and sedimentation. You needed to know then what you do with each of these layers to make it safe then to dispose of or use, and you needed to know that the effluent is treated then by a process called aerobic digestion, or treated with bacteria in an aerobic under aerobic conditions, whereas the sludge is treated with anaerobically, so anaerobic digestion. That gets rid of all the harmful microbes and bacteria and whatnot, and then you can chuck it on to use it as fertilizer and stuff. Apparently, there we are. That's that one. No more on that. Seawater and groundwater are treated differently to sewage, though. So groundwater just means non-salty water that you might find in rivers and reservoirs and aquifers and things like that. Seawater, of course, is salty water. So depending on where in the world you are or what your situation is, will decide what approach you would take. It's much harder to treat seawater, but for some people they have no choice. Groundwater is a lot easier to treat. And let's think about the reasons why as we go through this question. Seawater is desalinated. Desal, so sal meaning salt, sal meaning salt. Desalinated is what is removing salt, right? So be careful about that one. So which concentrations could represent X? Right, so we start with quite high concentrations of sodium ions and chloride ions in the seawater, and then it undergoes desalination using a process called reverse osmosis. You might remember that requires a huge amount of energy. You're expected to know that, much more so than, say, filtration. And so it's going to be a smaller number than in the first place. So it ain't going to be that answer, ain't going to be that answer, and it ain't going to be that answer, because in each of those, the chloride's not gone down at all, the sodium's not gone down at all, the sodium's not gone down at all, the chloride's not gone down at all. They both, the concentrations of both of those decrease, so you get the mark for ticking that one, which most of you did. But why are I thought this question was hard to get the marks actually, but why were the concentration of sodium ions and chloride ions unchanged by the first process, which is filtration? So you're told so much in this question that it's quite hard to get the marks, I thought, but you simply have to be referring to the filter really. So the ions pass through, they're really tiny, aren't they? So they pass through, or not trapped by the filter. And even though you're sort of told this in the question, you have to be really clear why that would be, and it's because they're dissolved in solution. Dissolved in the water or in solution. So that's why they can pass straight through. When particles are dissolved in water, they're not solid, so they're not going to be trapped by a filter, are they? There we go. That's that one. Question 5.4 is explain why the groundwater requires process 2. Process 2, by the way, was exposed to ultraviolet light. So why do we have to treat the groundwater with ultraviolet light? You can use, by the way, ozone as well. Is that in the question? You can use ozone as an alternative to that, or you can bubble chlorine through it. There's a few ways of treating the water. So the whole purpose of treating with ultraviolet light or chlorine or ozone is because the groundwater, even though it might have very little in the way of sodium and chloride ions, there might be microbes in there or pathogens in there which are harmful to health. Or words to that effect. So then you have to do this process of sterilisation. And really, I was looking for that mark looking for that word for the mark. Or you could have said killed the microbes or destroyed the microbes as well for that second mark. Okay, but sterilisation, using in the question it was UV, but remember you can use ozone or chlorine for that as well. Again, I think question 5.5 is a kind of awkward question. What you are required to know, one of the first points of the specification in this topic is you understand the difference between pure, when we say it from a kind of chemistry point of view, which means nothing other than the chemical you're talking about. So pure water for chemists would be simply that molecule and nothing else at all. But that's not what it means in layman speak. In other words, to speak of sort of normal people, lay people, including the company. And all it means to them is that it's in its natural state, or nothing is added to it, or contains no microbes was allowed as well. So, but really it was looking for kind of nothing added to it. So simply treated with the filtration and then the ultraviolet light, and that's it. So chlorine is used to treat some groundwater. Describe the test for chlorine gas. Just simply learning this is important. So damp blue litmus paper. I think you got away with saying just damp litmus paper. Damp blue litmus paper. Bleach is white. And you might know that it goes red first, but you didn't get a mark for that. Okay, so it's bleached or turns white. Question 8. I'll do it in a minute.